This is incredible. Earlier they were telling people to talk about in one word to describe the eclipse. The word for me is majestic. A lot of times, I don't know about you, sometimes
in the air from NASA's Gulfstream 3 aircraft off the coast of Oregon, we anticipate this awe-inspiring celestial event. Over the next 3 hours, we will track the solar eclipse as it moves across the entire United States from coast to coast, observing this incredible event through the eyes of NASA. Hello and welcome. I'm Dwayne Brown from NASA's Office of Communications. And over the next 3 hours, we're going to look through the eyes of NASA and experience today's total solar eclipse. I have a great team here on stage. Joining me to my immediate left is Jadi Collado Vega.
Hi, everybody.
Who is a space weather scientist. Solar scientist next to her, Alex Young. Over to my right, John Yimbrick, who will be taking your social media questions today. Plus, media specialist and meteorologist. Very important man today, I must say. Tracking the weather conditions.
So, how many eclipses have you seen?
I went to see 9 eclipses and I actually landed up seeing 6. The other 3 had inclement weather.
Oh.
We don't have that here today.
No, we don't, and it's going to be 7. So, what can you tell us about the sun that'll help our audience understand better?
I just want to start by saying I'm in awe at this moment right now. And whatever I say, kind of take it with that filter because we are very close to totality.
We are.
We live in the outer atmosphere of this magnificent, dynamic, magnetically variable star that dominates every cubic inch of space in our solar system. And if I can get the video, what you would see in the video is that the sun produces storms that can be all engulfed.
To take it back to NASA Eclipse Central in Charleston. Take it away, Dwayne.
Okay, now, just now coming in, we have an exclusive sneak peek of the total solar eclipse, and it is arriving at the United States. It's over the Pacific Ocean and about to reach Oregon. This is the celestial event that we've all been waiting and anticipating for years. We'll begin looking through the eyes of NASA out the window of our G3 aircraft. Let's take in the view.
Wow.
And now we're looking at the first glimpse of the total eclipse from the ground. Wait, let's see. That's still the G3. There we go. And now we're looking at the first glimpse of the total eclipse from the ground on United States soil. This is coming to us from Salem, Oregon, where thousands of people are gathered and experiencing this monumental event, a total solar eclipse. Let's take a look and take in the view.
Oh my God, that's so pretty.
That's the G3 there.
It's breathtaking.
Is that the real thing? Is that the real?
It's amazing.
We're going to keep that up and then we're going to do reactions. Okay, so
as the moon has now moved, the sun is appearing again, and we can see the diamond ring. It's amazing. It's fantastic. You see the outer edge. I see prominences, little red pieces of chromosphere from the lower atmosphere. This is amazing. This is absolutely amazing.
Jody, what we got?
It is,
that looks pretty cool.
I mean, it's breathtaking. I just, even seeing it right now through the TV, it's just an amazing thing to see. I cannot imagine what we're going to feel here in South Carolina when we have our chance.
Well, I hope we have our chance to, you know, Sean, you know, get that weather up here looking good here in Charleston. Now, what do we,
so Alex,
Alex, what are we seeing here?
Is that from the G3? That looks like from the G3 because I see spectra there.
No, it's still from Salem.
That's still from Salem.
Yeah.
Okay, so you're seeing the bright, actually the camera is causing a little prism effect there, and you're seeing the bright light from the edge of the sun. So that is really beautiful. That's sort of the edge of the diamond ring effect.
Yeah.
So Alex, a reminder, Alex, so when that diamond ring pops up, that's when people should put the
That's when people should put your glasses back on. So when you see that diamond ring after totality, that's the signal to you that it's time to put it back on.
Yeah.
So look now, we see the corona in Madras. That's gorgeous.
That's amazing. I mean, being able to look at that with your own eyes is an amazing experience, and that only can be seen when you have this kind of totality.
So the corona, that's the
solar atmosphere.
That's what solar scientists really live for, right?
Right. Right. That is the origin. That is where the origin of space weather.
Yes.
You know, that's where it comes from.
That's where most of the solar flares and the corona mass ejections, big explosions of particles, originate from.
Now, if there was solar activity, would we see it right now? Would we be able to see that popping up on the sun?
If there was a coronal mass ejection leaving the sun, we could see it there because, in fact, we have seen it in the past, and I'll even show some history later with images that people drew of these coronal mass ejections leaving the sun during a total solar eclipse.
Now, why is it so critical and so important to really get this type of view from the sun's atmosphere from the corona? Johnny?
You mean like in a total solar eclipse?
Yes. There's the diamond.
That's the diamond ring again. That's amazing. That's from Madras.
Wow.
It is important to do this because we do this kind of eclipses artificially, but we do not do it as perfect as nature does. The moon covers the sun in such a perfect way that we see parts of the corona that we don't usually see.
So Alex, explain that and safety too, right?
So right now, this was the moment when you see that flash of light. That's the moment when it's time to put your glasses back on or start using your indirect methods, because now it's too bright and it could damage your eyes.
Yeah. Safety first, people. Always.
Wow. So the folks in Salem, Oregon, I mean, they're like juiced. I mean, they got it. They got the good.
They've got a perfect view, and they are seeing one of nature's most amazing spectacles.
I can only imagine the reaction on the ground from the folks there.
Oh, they are probably completely overwhelmed right now. Completely overwhelmed.
Well, I certainly hope we get something like that. But we've got it here on NASA television through the eyes of NASA. And we got the International Space Station coming up and other images only we can bring.
Only NASA can bring, yes.
Now, is it completely dark or is it coming out?
No, what's happening now is the filters are back on, the safe solar filters for the telescope, and now you see the crescent, which is the sun, basically now being revealed after the eclipse. So we're now back to the partial phase in the other direction.
Exactly.
Now, how fast is this going?
Well, this shadow is passing across the country, depending on where you are, anywhere from 1,200 to 1,800 miles an hour. So this is moving incredibly fast because the moon itself, in its orbit, is moving at almost 3,400 miles an hour. And that, in combination with the rotation of the Earth, is what gives us a shadow moving that fast.
Okay, so Gotti, let's talk about space weather. Seeing this and space weather is so important. So just let us really understand why it's important on space weather.
So space weather is pretty much the conditions created outside in space due to the sun. We look at space weather because we want to understand these conditions. If you look at the image that you have now, you're going to see SDO image, the Solar Dynamic Observatory. That's where we actually look for the source of space weather, where the solar flares and the coronal mass ejections actually originate from. Well, when we look at SDO, at the images, we also have to look at artificial eclipses, like the one that you're looking at online now. These are actually from the SOHO spacecraft. These are the artificial eclipses that I was talking about, Dwayne. Like this, you have to block the solar surface to be able to see the solar atmosphere, the outside corona. But you're going to see something like this today, and you saw it. But you're going to see it better because nature does it better than we can actually do it artificially. Right now, the activity is not, there's not too much going on in the sun. However, if I do a historic event, which actually was from this past July, you can see a coronal mass ejection, this big explosion of particles that come from the sun.
Well, those look pretty intense. So we have to worry about that? That doesn't look good.
Well, you know, space weather, what can actually do is affect communications. We have the magnetic field of the Earth to actually protect us. It's our shield. And what we do is we actually can analyze that using real-time models like the one that you're seeing on the screen, that we actually understand how the magnetic field of the Earth changes with those coronal mass ejections. But space weather can affect communications, satellite instruments, and power grids.
Okay, so we're going to toss to Idaho. And I think we've really got some good stuff here. Gay Hill, are you there in Idaho Falls? In Idaho Falls?
I am absolutely here, Dwayne Brown. In fact, looking through the glasses right now, it's so weird we have a crescent sun instead of a crescent moon. This is I think we haven't had a total eclipse here in Idaho Falls since 1889, 128 years ago, and things have certainly changed in Idaho Falls since then. There's a whole lot more people, especially with all the visitors in town. We're just outside the Museum of Idaho, and we have partnered with the museum to make this an official viewing site for Idaho, and they right now have an exhibit on space, but we also sent in a team of experts, and for the past 3 days we've had talks, we've had demonstrations, we've shown them visualizations such as eyes on the solar system, and we've shown them artwork. But really, the order of the day is the eclipse, and NASA has that covered too. They have sent an army of volunteers. We call them solar system ambassadors. They are all along the path of totality, and they're volunteers. These are people just telling people what they're seeing and helping them understand. We have one here, right here. His name is Richard Stember. Hey, Richard. He has been manning this mobile observatory, and that is what is providing our solar telescope shot right now. Now, we asked him, what's it like being a solar system ambassador? And he said, follow along. We did, and we went with him to a school in Southern California. Take a look. All All right, we apologize. There is no audio on that video, but it talks about the solar system ambassadors. There are about 720 in the United States. They get special training from NASA. They learn all about the missions and about the science, and they basically go out to public events all over the country teaching them about NASA missions. If you would be interested in becoming a solar system ambassador yourself, you can. We have a website. Look it up, Solar System Ambassadors. It is a NASA website, and starting September 1 through the end of the month, you can sign up to be a Solar System Ambassador. So check it out on the web, Solar System Ambassador. With me now is Jim Green. Jim Green is the head of planetary science for NASA. He's in charge of all planetary missions and asteroids. This guy knows his stuff. Let's talk about this. Now, you see this eclipse that doesn't happen. It happens once in a lifetime.
Wow.
But as a scientist, you see it as an opportunity.
Oh, absolutely. I mean, we're getting the eerie feeling right now, but when we launch balloons, and there'll be 57 balloons along the path, 30 of which are going to have a planetary experiment on them.
And we have video of this. Now, just a few days ago, we had a crew here. They did a test launch for us, and they sent up an imaginary payload for us just to see how it all works. You have actual scientific experiments going up.
We do. We have a bacillus. It's a harmless bacteria. We have on 30 balloons 2 coupons where the bacteria will be sprayed. One will stay on the ground, one will be affixed to the balloon. It then will go up to 100,000 feet above the ozone. So the ultraviolet light, also blocked a little bit by the moon, is just like Mars. In addition to that, the temperature and pressure will be just like Mars. So when the balloon goes up higher and bursts, comes down, we'll retrieve that coupon off the balloon, match it with the one on the ground, and then we'll see how many survive.
Now, why is that information so critical for Mars research?
Well, this bacteria is pretty much everywhere. It's very hardy, and it probably has made its way to Mars, perhaps even on our rovers. And I would like to know if that environment is so harsh that it would eliminate that bacteria or not.
All right. I'm being selfish. I have never seen a total eclipse. And I'm sorry, I would love to talk to all of you people, but I want to put on my glasses too and take a look. Can we continue this conversation?
I have to do this too.
All right, and watch, and we can talk. All right,
oh,
so
what
we
a
still...
little sliver.
Just a little sliver of the sun right now. And let's talk about this. Why is this so rare?
Well, you know, the plane of the moon relative to the Earth's sun line is tilted by 5 degrees, and so there's only 2 places where the moon and the Earth and sun are on that same line, and that's why every 18 months or so we get an eclipse.
The shadow is 1 minute out of Idaho Falls.
1 minute away. Wow.
Crowd is getting excited.
Wow. It's already so eerie.
Wow, it just got dark all around us. And you can feel the temperature getting colder
Oh,
here.
yeah. The winds are really picking up. You know, this dark area, the winds are just flowing in.
Oh, you can... It's just a tiny, tiny sliver right now.
360 degree sunset. If you can see, and the shadows are now sweeping in from the left.
It's all closing up.
There it goes. It's going. Getting smaller. Oh, look at the ray structure. You can't get that on film. There's Venus.
Oh, wow!
There's Venus. Oh, wow. Wow. Oh, look at that ray structure.
You were saying this is the only way you can see the atmosphere.
Yeah, that lower part of the corona is really even hard from space to see. Wow. Wow. I got to spend a second looking around at the crowd. Oh my goodness. Yeah. Wow. Wow.
We should turn off the lights.
All right. You get ready to put them back on here soon.
Okay.
Pretty quick.
Have you noticed, Jim? The street lights are all on around
The street
us.
lights turned on,
We
of course.
confused the street lights.
Of course. Who would have thought that? We didn't plan that one.
All right, we should get ready for our glasses again. Get ready with your glasses.
Okay. There it goes. There's the diamond ring. There's the diamond ring.
Oh my gosh.
Yeah, wow.
That is
Was
so...
that all right?
Oh my gosh. Whoa! Oh, that's brilliant.
All right. Wow.
Okay, glasses back on.
Too brief. Too brief. Too brief.
Okay. We're going to have to wrap this up pretty soon, Jim. That was incredible.
Way too brief.
Yeah.
Way too brief.
We got a minute 50 seconds.
Yeah.
That was all we had. Why is it that some parts of the country get a little more than we do?
Well, it has to do with the curvature of the Earth also. And so the shadow is at various altitudes. You could go up at a higher altitude and get also a great view too.
Well, this was a real treat. This was fantastic. So Idaho Falls has had its total eclipse. The next one is coming in 2252. We won't be here, but we hope NASA will. Back to you.
Well, Gay Hill, that's Gay Hill from NASA's Jet Propulsion Laboratory. Gay, I'm jealous. I'm telling you, I'm jealous. So, Alex, explain again that diamond.
Well, so the last bit of sunlight, when you see it at the very beginning, is when the last bit of the sun, the crescent, shrinks down to a little tiny bit. And at the same time, you can see a ring of the corona around it, so that makes the ring, and then that bright bit of crescent gives you the diamond. So when it reappears, you get the same thing. The last bit of corona is a ring. The flash of the sun is the diamond, giving you the diamond ring. It's a beautiful, beautiful sight.
And real quick, and then I'm going to ask you a question because there was something going on here in Charleston. The planetary, Jim Green said something about Venus. This is really cool for planetary science because you can see other planets, right?
Absolutely, and as a matter of fact, one of our missions through the WB-57 aircraft are studying Mercury, which is very, very close to the sun.
Okay, so we're gonna come back to you, and we're gonna talk about what's happening here. So the next up, NASA's ready to take a bite out of the Big Apple, one of my favorite cities, Jody, New York City. New York City. Today's broadcast is being shown, I believe, in Times Square on the Toshiba Vision screen, so the city can also enjoy the spectacular views of today's total eclipse. And we've got a great relationship with Toshiba, so a shout out to you guys. This Midtown Manhattan tourist location is always bustling with crowds. On the average day, over 300,000 people pass through Times Square. Alex, I'm going to turn to you. You know, New York, they're going to get a partial, but they have a rich history in solar eclipse.
They really do. So actually 92 years ago, on a cold January morning, New York City, Manhattan, and Queens experienced a total solar eclipse. The edge of the path of totality went from 95th Street to 97th Street. This was an amazing opportunity. This was the first time we sent up 2 dirigibles with the U.S. Naval Service for scientists to study this. At the time, we actually thought eclipses could be creating radio waves which mess with communication. But what in fact is happening is the sun itself is creating this disturbance. So studying the eclipse is actually telling us about the sun, which is creating these disturbances here on Earth.
Yes.
Okay, so this just in. I believe we have results from an experiment that occurred on NASA's Gulfstream 3 aircraft from NASA's Armstrong Flight Research Center. Karen Rohr is standing by with Thomas Zabukin, the Research Administrator for the NASA Science Mission Directorate. Let's go now to see what the instrument observed during the total solar eclipse. Kevin.
Ready, I'll ever be with this.
And we're back here at the G3 up over ocean off the coast of Oregon. And it was amazing, wasn't it?
It was outstanding.
And so for me, like, you know, at 25 years I did research on the corona. I saw it for the first time. It was my first eclipse. Was it your first eclipse?
My first eclipse as well.
Just absolutely amazing. And I want to talk about two things. First of all, the shape of the corona. You know, I saw the models, I showed the model, and it was remarkably similar. You know, I saw these streamers, these magnetic structures coming out like glows in specific directions, just like we expected. So I'll look for the analysis before we claim victory, of course. But the other one is that spectrograph you, Mike, you know, ran on board. And just before that the sun, you know, disappeared behind the moon, that spectrograph, of course, is spreading out the light in all its colors. Just before it disappeared, there is that one shot. And Laurie, I want to ask you whether you can turn it on. Do you see those specific kind of lines that pop up between the green and the red? It's just like we said, it's helium. Remember, that's how it was discovered, helium. We didn't know we had helium here. It was a new element. It was discovered that way. And then over there in the red, between the green and the red, is iron. Iron, a really hot iron, telling us that, hey, this atmosphere is really hot. And then a little bit over, it's another line, red. Well, what is that? Well, it's hydrogen. Well, so even though it's really hot up there and only 1 in a million or 10 of million particles are neutral, it's still visible in that one shot that you saw. So Robert, back to you here, back on Earth. What did you feel like? How did you see this occur?
Yeah, so it was fascinating to watch actually the shadow or the path of totality underneath us. We're at 35,000 feet, and you could see at totality, you could actually see the darkness down on the ground. And you could look north and south and see where it wasn't completely dark. And as we kept going, you could just watch that darkness move. It was almost like a thunderstorm moving across the plains, but it was all the darkness, and it was just stunning to me to see that. So really, really good stuff, and I wasn't expecting that. And of course, the eclipse itself was beautiful, but seeing what happened down on the ground level of Earth from 35,000 feet was amazing. I just got to tell you, the team on this plane and the team all the way around this country is just doing a fantastic job. I wish you could have seen the folks here working to make sure we got the data that Thomas showed. Some fantastic images we've already looked at that I can't wait to share with everybody and for everybody to see. But really exciting to watch this team work, and the pilots did a great job. We had a little bit of a challenge right at the time of when we needed to be best, but they did a great job recovering from that, and then kept us on path all the way through. So anyway, so thank you guys. Remember to put your glasses on for those of you who hadn't seen it yet, and we'll talk to you soon.
Fantastic stuff. And if you just tuned in here, you're watching Through the Eyes of NASA, NASA television. We have the best views of the solar eclipse today and coming later in the show. You don't want to miss this, the International Space Station live. Now, next up, let's visit a working farm at Austin Peay State University in Clarksville, Tennessee. Agricultural observations and solar eclipse viewing activities are underway, including high-altitude balloon launches and painting cows.
Painting cows? What?
Okay, all right. So now let's go to the NASA Marshall Space Flight Center. Chris Blair standing by.
Well, humans are naturally excited about the solar eclipse, but one thing we've learned on this working agricultural farm is that animals can as well. But more on that in a moment, as right now we're getting ready to do a live scientific balloon launch. And joining us to tell us more is Dominic Critchlow from Austin Peay State University. Thanks for joining us. We appreciate it. So tell the crowd and our audience a little bit about the scientific payload you have on board.
Yeah, thank you for having me. Today we're flying some still image equipment, and we're going to be taking images of the ground in different wavelengths. And we're also flying live streaming equipment, so we can live stream the eclipse looking downwards and looking around, and at 100,000 feet, which is higher than any plane has ever gone. We're also flying some biological samples with NASA Ames, and then our trackers so we can have a successful recovery.
Okay, and they've just released your balloon. So let's talk about the NASA science and the biological samples. Explain more.
So NASA Ames has contacted us and all of the other teams that are going to be doing launches today across the whole path of the eclipse. We're going to be all have a little chip of biological samples on today across the whole path of the eclipse. We're going to be all have a little chip of biological samples on there that are going to go up in the stratosphere, which is a similar atmosphere as we would see on the Martian surface. So we're doing some Martian studies, which is really interesting and cool.
We are very excited about that. And so also, how many balloon releases are you planning on doing this today or this weekend?
And so all across the U.S., we have about 50 teams that are launching in the path of the eclipse so that we can have a full coverage of the stream. And on the site today, we have 3 launches from 3 different universities, and we're just really excited to be here, and hopefully all successful launches.
All right, so finally, these balloons do go up and they come back down. And so what's some advice if anyone finds one of these payloads out and about across the country? What's a tip you would tell them?
If you find it, leave it there. Maybe take a picture because it's kind of cool to see something land in your backyard from research. And please don't touch it. We'll be there soon to pick it up. If you have to move it, let us know, and we'll just be there to recover it.
Awesome. Thanks. We appreciate your time.
Thank you.
Appreciate it. Okay, so yesterday we had a chance to catch up with some serious students, albeit a little younger, but serious about doing real-world science nonetheless. And here to tell us more is my good friend and colleague, Mitzi Adams from NASA's Marshall Space Flight Center in Huntsville, Alabama. Mitzi, thanks for joining us. We appreciate it. So tell us about the science that these high school students are working on.
Well, the students are actually working on some atmospheric science experiments. They're doing animal study experiments, and they're helping us observe the sun in various wavelengths of light.
And these students aren't just from the Clarksville area. I understand they're all around the country, if not perhaps the globe.
The students are from the U.S. Space and Rocket Center, and yes, they are from all around the globe. And they're actually from the Inspire project as well. They're participating in VLF radio noise experiments, and those folks are from Washington, D.C.
All right, excellent. So you mentioned the Space and Rocket Center, Space Camp. That's the official visitor center for NASA's Marshall Space Flight Center. Feel free, if you're in northern Alabama, to come and see us. They do a great job of representing a past, future, and present history of NASA. So any parting words?
Well, you know, in the words of Frank Reynolds, I'd like for us to remember for the next American eclipse in 2024, let the shadow of the moon fall on an earth at peace.
Very poetically done. We appreciate it. All right, so up next is, as promised, our Animal Lovers segment. And so here on the agricultural farm, students are studying really cool STEM fields. So it's conservation management, it's veterinary medicine, animal biology, and so they're interested in animal behavior. And so joining us is Dr. Donald Sudbrink, head of the Ag Department here at Austin Peay State University. And so it's not cow tipping, it's cow painting, correct?
Yes. We had to paint the cows that are in this study to see what sort of things that they would do so we could record the individual animals so we could see what behaviors that they were exhibiting.
So we saw the cows, and the students were involved with that Mitzi just spoke about. And we're also talking about cricket behavior and cricket observations.
Yeah. Yes. Well, we're also talking about crickets. I'm an entomologist by training, and crickets generally chirp at night. So we're going to get a chance to see a series of isolated males and see what they do when the sun goes out.
Okay, excellent. Well, glad you all are doing this kind of observational research. Really appreciate your time.
Thank you.
Thanks a lot. So, and speaking of time, it's almost time for us, everyone here at Austin Peay State University, to actually watch the solar eclipse. So let's go back live for continuing coverage of NASA's eclipse across America from Charleston.
Okay, so, Yadi, I wonder if the milk tastes better when you paint the cows.
I don't think so. I don't think so.
All right, let's go to social media. We've been in the show here, and I know it's a buzz. So over to John Yerbrick for social media update.
Yeah, last time I looked, Dwayne, there were 2.1 million people looking online on our website, on our 1.2 on our live stream. So it was a huge conversation, and Solar Eclipse 2017 is still trending #1 on Twitter. So it's been huge. Can we go to the first slide here that I've got up? This right here is an amazing photo. Sometimes they say you have to be at the right place at the right time. This is taken by one of our NASA photographers, Bill Ingalls, out in Washington. And he captured, it's hard to see here in this pic, but he captured the International Space Station transiting the sun during the partial eclipse there in Washington. Pretty amazing. You kind of have to look closely. We'll also be putting these images up online if you want to see them. But one of those little dots there is the International Space Station traveling at 17,500 miles per hour. Here's another one from our photographer in Wyoming. Same concept, capture the space station. We knew exactly when the space station was going to be flying, what its orbit was, and when it was going to cross the sun. And look here, it's just an amazing sight. I'm really proud of our photographers for getting these shots and proactively trying to get something that no one else probably has and thinking through and getting this great image. So let's take a few questions from social media. I want to remind our viewers at home that you can ask questions to us here on the set and on social media with the hashtag Eclipse 2017. So why don't we bring it back here to the stage. First question is from Twitter. What if we wear sunglasses instead of eclipse glasses? Will we actually be able to see the eclipse? The sunglasses help? Does it give you any sort of protection?
No, that's definitely a no-no. You should not wear sunglasses, normal sunglasses. Always wear the actual sunglasses that are made for solar viewing, like the ones that I'm having here right now in my hand. And if you don't have the sunglasses, you never look directly at the sun. You look like you do an indirect projection of that eclipse. Never look at the sun without the proper safety.
So another question here comes from Deborah from Facebook. So the sun rises in the east and sets in the west, and the Earth rotates in clockwise motion. Please explain how it starts in the west and ends in the east.
Well, so the Earth is rotating from west to east, but actually the moon is moving faster, about 3,400 miles an hour, casting a shadow down on the Earth, which is rotating about 1,700 miles an hour. And that actually means that the shadow is moving from west to east across the Earth at about somewhere between 1,200 to 1,800 miles per hour, depending on where you are on the Earth.
Okay, great. We have another one. I think we have time for another one. Tina from Facebook's asked, if I place a lens from the eclipse viewing glasses over a viewfinder on my iPad, could I successfully video the eclipse, or would it fry my camera?
Yeah, you can actually look with the iPad or your phone to the eclipse. The only thing is, you have to be very careful not to look at it with your own eyes without the actual safety glasses. Never look at it through any lens.
Okay. This is Mickey from Facebook. Hey, NASA, can the International Space Station see the shadow of the moon crossing America from space? Do they have that view when they're looking from space?
They do, and that's what we're hoping to see from them. Yes.
Excellent. So, John, we're going to come back to you. So I think we're going to go back to Sean, our meteorologist. Let's learn more about how NASA is studying the Earth and Sun relationship during this eclipse. Sean, can you tell us more about that?
Right, thanks, Dwayne. So during the eclipse, the moon acts like a giant cloud as it passes over areas in the path of totality, casting a large shadow on Earth's surface. Now, the footage you're seeing right now shows a solar eclipse that occurred in March of 2016 over Indonesia. That experience helped us determine how best to study today's eclipse. These images were taken by NASA's EPIC instrument aboard NOAA's Deep Space Climate Observatory, or DISCOVER. It's just one of the instruments we'll be using today to study the eclipse as we monitor changes in Earth's energy balance. Scientists have made extensive atmospheric measurements during eclipses before, but this is the first opportunity to collect coordinated data from both the ground and from a spacecraft that observes the entire sunlit Earth during an eclipse. Dwayne, back to you.
Thank you, Sean. Okay, so now we have a special guest with us today, the Associate Administrator for NASA's Office of Communication, Jinray Wong. Jinray, welcome.
Dwayne, thank you. So happy to be here.
Oh, it's an exciting day. I'm glad you to join the team here. And our next location you are pretty familiar with, I'm sure.
I'm very blessed, and I do know something about the great state of Nebraska. I've actually lived there for the last decade, and I have friends and family who are watching there from the path of totality. I have to tell you, this is by far the biggest thing that's happened in Nebraska as of recent. It's absolutely fabulous. I have had friends from high school and college calling me up, Facebook messaging me, asking where they can get their glasses, where they should be viewing from. So it's just a really exciting day for everyone who's watching along the path of totality. It's also a really exciting day for NASA. And in fact, this gives us an opportunity to look forward as well. And we have a future study that we are going to be doing for to study the sun. NASA is going to launch a new spacecraft next year, the Parker Solar Probe, and it will fly directly into the solar atmosphere. The mission will provide first-of-its-kind data. And for more information on this future mission, let's go to Beatrice, Nebraska, where Vince Whitfield from NASA's Langley Research Center is standing by. He's at Homestead National Monument, where the National Park Service has coordinated an eclipse viewing. Vince?
And Just in, I think we're having, Vince is going to come up shortly, Jen Ray, so we're going to go back with an image, but we will be doing Nebraska as soon as we can. So a shout out to the great state.
Thank you. First shot.
Okay, folks, Jody and Alex, this is a different view here. What are we seeing, Alex?
Well, so we're looking at a different wavelength of visible light. It's called calcium K. So this is light that's produced by excited calcium. And this is showing us the sun as the moon is moving over it. And in fact, if you look over to the left, on the edge of the sun, you actually see sunspots.
A sunspot, yeah.
And these are regions that heliophysicists like myself and Jari are most interested in, because that's where solar explosions originate from. In fact, the magnetic fields that come up into the corona that we see during the total solar eclipse originate from those sunspots.
Actually, this sunspot had a solar flare yesterday.
Right, and I believe this is coming from Carbondale. So that's now it's why is it purple? Is that what's the color?
That's actually the light and the color of the light in the filter. The color is a bluish light, and so it comes out as a purple color. But it is a type of visible light. It's one we look at quite often from both space and the ground and look in the sun.
Now I see some black thingies, look like a little river. You see it over there near the corner on the left?
Yeah, that's the sunspots.
Now, what's a sunspot, just for our audience here?
Those are the regions where most of the space weather actually originates. The solar flares, the coronal mass ejections are regions of the sun that have very complicated magnetic fields. And these are where most of the magnetic energy is actually released.
Right, so those are regions of super intense magnetic field, 1,000 times stronger than the Earth's magnetic field. And those have lots of energy, and they drive space weather.
Okay, I think that's why we didn't get the Nebraska feed right now. Those things cause that, I think, right?
That's right. We're getting a little glitch.
Hopefully we get Nebraska. Okay, Sean, we're going back over to you. Talk about moon shattering.
That's right, Dwayne. We've got some really incredible imagery for you. This is again from the GOES-16 weather satellite, just launched last year by NASA for our friends at NOAA. And what you're seeing in the western portion of this image is actually the moon's shadow being cast over parts of the path of totality. And of course, you see the cloud cover across the U.S. as well. And as I was telling you earlier, it's actually looking pretty good for most of the western parts of the U.S. that are in the path of totality. Not so good for maybe parts of the central U.S. Where we've got some thunderstorm activity developing and expected to develop later today, this afternoon, for places like Nebraska, parts of Nebraska and Missouri and northern Illinois, so maybe north of Carbondale. And then gets better again as you see in terms of cloud cover as we move further east toward Charleston here. But here in Charleston, we still have some breaks in the cloud. Where the sun is, it's still obscured. But we are able to actually see some of the partial eclipse here in Charleston through some of the breaks in cloud. But again, really wanted to show you guys that imagery from GOES-16 satellite from NOAA showing you the moon's shadow actually being cast over parts of the western United States right now. With that, Dwayne, I'm going to hand it back over to you.
Thanks, Sean. Now, as a reminder, our broadcast is tracking the total solar eclipse as it crosses the United States. It's moving along a path of totality. That's a 70-mile wide path sweeping across the entire nation. Over 12 million people live inside the path of totality, plus it's estimated that close to 7 million people have traveled to cities within the path of totality. I know that today is truly a day of celebration as people gather in cities and festivals to view today's celestial event. So let's get into the cultural impact here, guys. Alex, what's your take on the cultural impact of these eclipses?
Well, you know, this is really such a fantastic opportunity to connect the nation and, in fact, the world with one of nature's most amazing celestial events. And this is something that we, as working at NASA, are really excited to be able to share. And in fact, we even work with some of our colleagues in other parts like the U.S. Postal Service.
Yes, the U.S. Postal Service actually created a special stamp for this event.
Right. So what I want to do, let's talk about the stamp.
Sure.
But Jen Thompson, Nebraska, the sunspots are gone, so let's go to Nebraska. Vince Whitfield, are you there?
Hi, we're at the Homestead National Monument of America. This is a great location to watch the eclipse, and we've staked out a good spot here on the prairie. Even though the weather isn't cooperating, this is still an excellent event. We're also very prepared. Please make sure to use your protective glasses when viewing the eclipse wherever you are. You can cause serious damage to your eyes if you don't take precautions while watching. And there are a lot of people watching. As you can tell, the festivities, just like the eclipse, are in full swing. I'm joined by Chief Park Ranger Susan Cook.
Hey Vince, how are you?
Great, Susan. Thanks for joining me today. Please tell us about this amazing place and what's going on behind us.
Well, we are at Homestead National Monument of America. We are a national park site dedicated to telling the story of homesteading. 30 states, 4 million people, 10% of the United States was homesteaded. The head of a household, anybody could own land as long as you could be a U.S. citizen. You got 160 acres. It's how we settled the West. We built our democracy, we built our economy, settling the West through this law.
That is just so interesting. Now, I understand the Mayan calendar followed the solar eclipse calendar closely. Is that correct?
It did. The ancient Mayan used several different calendars to organize their secular and spiritual lives. Many of these calendars had strong roots in the motions of celestial objects, especially the sun and the moon. And the Hub calendar is a solar calendar of 365 days, subdivided into 18 months of 20 days, plus 1 month of 5 days. Another calendar is a Tzolk'in, made of 260 days, subdivided into 13 months of 20 days. This calendar also has a resonance with eclipses, which occur about every 173 days. Every 3 sequences of eclipses aligns every 2 cycles of the Tzolk'in. Who could keep track of that, frankly?
It's just amazing. Now, as a Chief Park Ranger, I have to congratulate you. This is a fantastic venue. Tell us about some of the activities you have planned.
Well, actually, right now you can feel it getting darker, but we have stage performances going on. We have many NASA scientists. You can learn about planetary defense, how do we defend our world. You have NASA scientists doing other things. We have Native Americans. We have a Mayan Calendar Sky program. We have folk music. We have all sorts of fiddle music.
Lots going on.
Lots of things, balloon launches. So there's things all around us. It's really exciting.